We are all familiar with this from our various secondary schools. So that's the parallelogram representing the forces we have in consideration, under consideration in this case. P and Q. The angle between P and Q is theta. Together they produce a resultant capital R. The angle the resultant makes with P is alpha. To
Sir,
the right,
please,
there's
we
a right
cannot
angle
hear
triangle.
you because of this favor girl.
Sir, please, you can mute her yourself. You can mute the favor by yourself because she's distracting us.
Can you hear me now?
The girl is really disturbing.
Then they should kick her out.
Can you hear me now?
Yes, sir.
Yes, sir.
Yes,
sir.
Loud and clear.
Okay.
Yes.
Is this class for
We're adding two vectors
students?
P and Q, and the angle between them is theta. The resultant makes angle alpha with P. To the right, there's a right angle triangle. Of course, you can see Q sin theta, that's the opposite. If you consider theta as the angle under consideration now. Then the one adjacent to theta is Q cos theta, as we said in the last meeting. So we shall consider the magnitudes of capital P and capital Q vectors as P and Q that are normal formed. From the parallelogram, of course, it is clear that P plus Q equals Q plus P, coming from what we learned in the last class. If you go through the left, that will be Q plus P. If you go through the right, that will be P plus Q. Now, from cosine rule, R squared will be equal to P squared plus Q squared minus 2PQ cos 180 minus theta. We all know that cos 180 minus theta is minus cos theta because 180 minus theta is in the second quadrant. Cosine is negative in the second quadrant. Hence, we can write R as being equal to the square root of P squared plus Q squared plus 2PQ cos theta. And from the right angle triangle, you can write, is the screen moving?
Is the class for
Yes, sir. Yes, sir.
Okay, tan theta will be equal to
Yes,
Q
sir.
sin theta over P plus Q cos theta. Let's go back to that page. Consider the triangle involving P and Q cos theta, and then the vertical part being Q sin theta. It forms another right angle triangle. You can see using Pythagoras theorem, Q sin theta plus Q cos theta, that is P plus Q cos theta in a bracket, all squared, plus Q sin square theta, Q squared sin square theta will be equal to R squared. And if you look at tan of alpha, it's going to be Q sin theta over P plus Q cos theta. Q sin theta over P plus Q cos theta. Let's take an example. We have two forces, 5 newtons and 6 newtons acting on a body, and the angle between them is 30 degrees. Calculate the resultant force and the angle the 5 Newton force makes with the resultant. R is going to be square root of P squared plus Q squared plus 2PQ cos theta, which will be square root of 5 squared plus 6 squared plus 2 times 5 times 6 cos 30 degrees. Put all that together and go to arrive at square root of 112.96. That will give you 10.6283 newtons. For the second part of the problem, we are arranged to make 5 to be on the horizontal. Therefore, P is 5 newtons and Q is 6 newtons.
Oh my nose.
Sir, please, I don't understand.
I don't understand.
Sir, please go back.
Please just listen first. Listen first before you complain, please.
Hey,
Result forces. We want to find the angle between them. So R squared is P squared plus Q squared plus 2PQ cos
Your
theta, which
screen is
is
not shared, sir.
equal
Your
to
screen is
R
not
squared
shared, sir.
minus P squared minus Q squared over 2PQ.
Sir,
That
please,
will be
you're not seeing the slide. I
10.683
wrote
R
there.
squared minus 5
Sorry, sir.
squared.
Hello, sir.
plus-
Hello, sir. Your screen is
Hello,
not shared, sir.
sir, your screen is not showing.
Your screen is
my
not
screen is
shared,
not
sir.
showing.
Yes, sir.
Sir, we can't see it.
It's the class
Let me
for
have to stop
engineering
sharing
students.
and share again. Okay. You can see the screen now.
It's loading. It's loading.
Let's see the screen now.
Okay, we can
Loading,
see it
okay.
now. We can see it now.
All right. So I have to start from tan theta again, right?
You can continue, sir.
Okay,
Start
two
from tan
forces,
theta
5
again.
newtons and 6 newtons are acting on the body. Is that okay to start from there? Hello? Hello? The angle between the
Yes,
two
sir.
forces is 30 degrees. And
You didn't get me. I think anything.
30 degrees.
I beg, I'll go.
Calculate
Yes, sir. You are breaking. You
the
are breaking.
resultant
Your
force
voice is breaking, sir.
and the angle the 5 Newton force makes with the resultant.
You suppose have better join
R
every class.
is going to
Why?
be the square root of P squared plus
Actually, sir, your voice is breaking.
No, yeah. I know hearing you. The class
You know my network no good.
only time of also engineering.
I
What is
feel
this
this
you see
problem with
me.
the noise?
Must you guys talk? Must you talk?
Is it
You
going
see
to
my
mute your mic now?
It's the class for engineering.
Nobody is actually talking.
Proceed,
It's the
sir.
favored girl that
Proceed, sir.
her
Continue,
background
sir.
is making noise.
Yeah.
So it's the class for engineering.
Voice. Hello.
We can hear you.
Sir, please,
Your
your
screen is not
screen.
shared again.
Sir, please, your screen
We
has
can't see your
has
screen.
gone or whatever.
Yeah.
Favor fine country. Favor fine country. What's your problem now?
It's the class for engineering
Someone
students,
does that house.
please.
It's possible. And to pay for teacher, please. God.
Just
Who be this favor sef na?
Sir, please keep this girl out. Sir, please, I
Favor,
beg, I beg.
mute yourself now,
Ah,
Favor.
more.
I don't think the favor is with her phone, so we should just remove her.
Please, let us remove this girl.
So
We
the
cannot
class.
remove her.
This
It
girl
has
never
to be
operate
a
her phone, so I
host.
just remove
The
her.
host
Yes, sir,
has
you can
to remove
remove
her.
Favor. You can remove her from the more. When you click more, you go to setting. You can remove her permanently.
Kick her out.
I just want to know if this class is for engineering. I've asked like 70 times.
Ask again.
I guess I didn't class.
Please, let's keep quiet.
Whether
Please,
it's
I beg.
engineering
all
or
right
I beg.
now.
Let's keep
Please.
quiet. Yes, sir, your screen is not shared, sir.
Okay, I've looked at two different methods. This is the third method.
Your screen is not shared, sir.
Sir, we can neither hear you.
Because of
Your screen.
Nor see your screen.
example,
We can neither hear you nor see your screen.
P and Q. The angle between them is theta.
Sir, we've not reached here. Sir,
Sir,
we've
please,
not
we
reached.
can't hear you. Please, can you guys mute yourself?
Cannot
It is his network.
I don't think we are here.
Sir, please, your voice is breaking
close
and
the
I can't hear
meeting
what you're saying.
completely.
Sir, we are not hearing you.
This is network.
So the X component
Man is talking to himself.
is
Sir, please, we've not reached this side.
cause 0, which is
So
P.
when will we get the slide?
And the Y component is going to be P and 0 because P is pointing along the X. You see what? It's not showing again.
Continue, sir. Continue, sir.
This balance now. Continue.
Go back to Thomas slide. Thomas slide.
Is it showing now? Loading,
Sir,
right?
please go back to your
Yes, sir.
previous
Yes, sir.
slide.
It's
We
okay. It's
weren't
okay now. It's
hearing you.
okay now.
Is it loading now?
Parents were here.
The previous slide.
Sir, please go back to
Can you
the
hear me
previous
now?
slide.
Can you hear me now?
We can hear
Yes,
you,
we
sir.
can hear you
Proceed,
now.
sir.
Can hear you.
We can hear you, sir.
We
Please
can hear
Hear
you,
me
sir.
now.
1989 doing so.
89. How much did you?
I'm not in this class. So, now 90 you count.
No, 89.
99.
89 I do. I'm not saying don't put 1,000 again.
Is lecturer talking? Is lecturer talking? Because I'm not hearing anything. No.
Your screen is gone again, sir.
He's having
We can't
network
hear you.
issues. You guys should chill.
She was all.
So you understand?
He's having network issues now. What do you want him to do?
You need like lecturer.
Come on. Is not for the weak.
Your screen is no longer shared, sir.
I come. Maybe I will come back. Or I go send my booking later.
But that means that method. You don't need to go through all these stories. You can take a look at them from the material already sent to you. Let us take an example now. There are 3 vectors: 4 newtons,
The
5
screen is no
newtons, and
longer
6
shared.
newtons.
The screen is no longer shared, sir.
I don't understand. Having to share every screen.
So I don't understand.
If you have to do that, then you have to do that. Is that okay now?
Oh, sir. Okay, yes.
Yes, it's okay now.
You can see
There
it
are
now,
3
sir.
vectors: 4 newtons, 5 newtons, and 6 newtons. And the angle the 4 Newton force makes with the x-axis is positive x direction is 70 degrees. The 5 Newton force makes with the 4 Newton force is 140 degrees. And the angle the 6 Newton force makes with the 5 Newton force is 130 degrees. You have to reckon all angles from the positive x direction. So you don't need to bother about plus or minus. That will come from the sine and cos of the angle. So the first one is going to give you 4 cos 70 degrees. The y component will be 4 sine 70 degrees. The 5 Newton force will have an x component of 5 cos 210 degrees and a y component of 5 sine 210 degrees. Just x direction will be component will be cos cos cos, y component will be sine sine sine, provided your angles are measured from the positive x direction. So likewise, the 6 Newton force, 6 cos 3 plus 2 degrees and 6 sine 3 plus 2 degrees. Together and arrive at Rx, what I call Rx and Ry. To get the resultant, square the sum of the x components and sum of the y components. This method brings to the fore another way we can add vectors, especially if the components are already given. We could have written the vector 5, 36.87 degrees in terms of its x and y components as 3,
Mommy, I can't see
Mute yourself now. Man, talk.
3i plus 4. As an example, add the following vectors. What is b plus equal to b? Just add x component to x component and y component to y component to arrive at minus I plus 4j. What is b minus c? Just as it is indicated, that's 3I minus 2j minus 4I plus 6j. You're going to get minus 7I. In general, if I give you two vectors, a plus b, a and b, and a is ax plus byj plus bzk. A plus b is the vector got by adding the x together, the y components together, and the z components together. A minus b is vector got as indicated on this. Can you see the screen?
Yes, sir.
Right, ax minus
Yes,
bx
sir.
I plus ay minus byj plus az minus bzk. Notice that this is nothing but the same as addition of vectors via the vector resolution method. Let us move on to position, distance, and displacement. The displacement of a body is the distance it moves in a specified direction. You can see it has a magnitude which is a vector measured in meters. Mathematically, we are going to define displacement as x equals final position minus initial position. It follows therefore that if the final position and initial position are the same, your displacement is zero. Can you hear me? Can still hear
Yes,
me.
sir.
Distinction
Yes, sir.
vector. So if you travel 5 kilometers north and come, your displacement is zero, but the distance is 10 kilometers.
Baba,
Goes 12 kilometers north
Baba,
to point B, calculate the magnitude of its displacement. What is it?
Sir, please, we
The
don't
angle the displacement
understand.
makes with the you don't understand.
Yes, sir. Yes,
Understand
sir.
what?
I don't understand. I don't
What
understand. From the beginning.
understand? What
Sir,
don't
please,
you
from the
understand?
beginning. From the beginning.
From the beginning. This is
You missed a lot
level.
of points. Sir, your voice was breaking, so I did not get everything you said from the beginning.
But we can read what is on the screen. Hello.
We can read what is on the screen. Continue.
This is all level stuff, please. This is all level stuff. I've not taught you anything levels here. Is that okay?
Yes, sir.
Most of you will recognize this as O level stuff.
Yes, sir.
Yes, sir.
So a man initially travels from A to B, the distance of 12 kilometers north to point B, and then 5 kilometers east to point C. Calculate the magnitude of his displacement, the angle the displacement makes with the x direction, and the direction traveled, and the distance traveled rather. You are of course familiar with this triangle, as we discussed in the 12 kilometers, 5 kilometers. That means the hypotenuse will be 13 kilometers. Angle theta is 22.6 degrees. Calculate that from opposite to adjacent. Who are these people?
I don't understand.
I will remove.
Your mic, oh.
Funnily enough,
Okay, later.
Okay, oh.
So they sleep.
Yeah.
the angle theta equals 22.6 degrees, which is arctan 5/12. So the angle the vector makes with the positive x direction, like this, the result makes with the positive x direction, is going to be 90 minus 22.6, which is 67.4 degrees. The distance traveled is 12 kilometers plus 5 kilometers, which is 17 kilometers. All you notice, magnitude of the displacement is always less than or equal to the total distance traveled. If you must calculate as you would in a theory paper, then AC will be equal to square root of AB squared plus BC squared, which is square root of 12
squared.
5 squared. That will be 13. And then tan theta will be equal to 5 over 13. So arctan 5 over 13 is theta, which is 22.6 degrees. Let us look at the concept of position and coordinates. In one dimension, take a look at what we have there. Vector x1 goes from -1 to 5. Vector x2 goes from 5 to 3. And vector x3 goes from 3 to -2. So x1 will be 5 minus -1. That is final position minus initial position, right? That will be
Yes,
5
sir.
minus
Yes, sir.
1, which is 6 meters. X2 will be 3 minus 5, which will be -2 meters. And x3 will be equal to -2 minus 3, which is -5 meters. X1 plus x2 will be 6 plus -2, which will be 4 meters. And then x1 minus x2 will be 6 minus -2, which is 8 meters. And x2 minus x3 will be equal to -2 minus -5, which will be -7 meters. Now, I've also drawn in 2 dimensions. You can see in 2 dimensions, we are going to have x component and y component of each of the points we have in front of us. So if you look at that, R1 will be final position, which is 0, 3 minus -2, 1. Can you see that? R1
So the slide hasn't moved yet.
has not moved. So I went back.
Yes.
So that you can see what I'm talking about. Can you see the rectangle, the grid?
Yes.
Yes.
I just went back there so that you can see. Look at R1. What's the final position? 0, 3, right?
Yes.
What's the initial position? -2, 1. So that tells you now that R1 will be 0, 3 minus -2, 1, which will be 2, 2, right? If you go back to the diagram, you can see that will be 2, 2. You are moving 2 steps to the right and then 2 steps to above that. Can you see? 2 to the right, 2 in the y
sir.
direction. That is 2, that displacement is 2, 2. Similarly, R2 will be equal to 1, 2 minus 0, 3. In the end, it's going to be 1, -1. If you go back to the diagram, you can see it is 1 to the right, then -1 down, which is 1, -1. So you can figure out all the other things.
So it's final minus initial.
Of course. So let us now look at relative motion. Frame of reference. A frame of reference is a set of coordinates with a clock attached as shown in the figure below, so that it is possible for us to measure distances and velocities. So every motion is referred to a frame of reference, hence the name. Why do we need a clock? We can measure distances using X, Y, and Z, right? We need a clock so that you can calculate the time taken, so you can calculate velocities. Every motion is referred to a frame of reference, hence the name. When you say a body is moving at 40 meters per second, you are in effect referring to a fixed frame of reference. Say a fixed spot on the surface of the Earth. So the body is in motion relative to that point on the surface of the Earth. You also imagine there's also a frame of reference attached to the body itself. With respect to this frame, the body must be at rest, right?
Yes.
Yes, sir.
Now, suppose you are in a train moving at 10 meters per second relative to an observer by the side of the rail track. So someone beside you on the train, you are at rest. That is, okay? You are at rest, having no relative motion. If you now move at 2 meters per second towards the front of the train, the man in the train sees you moving at 2 meters per second relative to him in his own frame of reference, which to him is at rest with respect to the train. The observer by the side of the rail track sees you now moving with respect to him at 12 meters per second. If you move at 2 meters per second towards the back of the train, the observer in the train sees you moving minus 2 meters per second relative to him. And the observer on the ground sees you moving at 8 meters per second relative to him. We shall see more about this under relative velocity.
Velocities.
Linear motion is motion in a straight line. Earlier, we discussed motion in the x direction. In this section, we continue with our discussion and also consider motion in the vertical direction. Let's look at speed, velocity, and acceleration. Speed of a body is the distance it travels per unit time. Since distance and time are both scalars, their ratio speed is also a scalar. The unit of speed is that of the ratio of meter to second, which is meters per second, as surmised from the equation speed equals distance over time. Example, a man cycles a distance of 80 meters in 10 seconds. Calculate his speed. The distance traveled is 80 meters, and the time taken is 10 seconds. The speed is 80 meters over 10 seconds, which is 8 meters per second. So far, when you go from one place to another, most times you slow down, speed up, and slow down again, on and on. It is almost impossible for you to maintain a steady speed. In such a case, the average speed is defined as the total distance traveled per unit time. So if you took a break, for instance, and you ate at an eatery and went back to your journey, then you have to add that time to it as well. If you slept overnight or whatever, you add whatever time you spent. Note that speed is always positive since neither distance nor time is taken as a negative. That is, time taken is taken as negative. A man leaves Lagos at 8 a.m. heading for Ibadan, a distance of 120 kilometers. He arrived at Toll Plaza, a distance of 50 kilometers, at 8:45 a.m. and stopped to buy fuel. At 8:50 a.m., he set out from the fuel station, finally arriving at Ibadan, 9:10 a.m. Calculate 1. His average speed between Lagos and the Toll Plaza. 2. His average speed between Lagos and Ibadan. That I'm sure you can easily figure out on your own, right?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Now, let's take a look at velocity.
Oh.
So we understand you,
Time rate of change of position. So
Sorry,
the vector measures
sir.
in meters per second.
No.
Okay. As in the case with speed,
No.
go back to your secondary school if you don't understand. If we define the average velocity as the change in position per unit time. So average velocity is final position minus initial position over time taken. What do you notice?
Sir? So please, can you...
So average velocity is final position minus initial velocity over time taken, right?
Yes,
What do
sir.
you notice from that graph?
Yes, sir.
It is not a linear graph, is it?
No, sir.
Yes, sir.
No.
So
Not a linear
that
graph.
average
We have a curve
velocity
in a straight
is
line.
the slope of the line drawn from T1 to T2, right?
Yes, sir.
Yes, sir.
Yes, sir.
You can see that line is just an approximation to the graph. So that's why we are talking about average velocity.
Okay. Okay.
Instantaneous velocity is the time rate of change of the displacement.
Okay.
And this can be achieved by letting T2 tend to T1 in the equation. That's the last equation on that page, on the previous page. That should be S2 minus S1 over T2 minus T1, right?
Yes.
You allow T2 to tend to T1, or you allow delta T, as you know in calculus, to tend to 0. I have a feeling that a good number of us took calculus, but I'm not assuming that we took calculus. So instantaneous velocity is the limit as T2 tends to T1 of S2 minus S1 over T2 minus T1. This is the slope of the function at time t equals T1. You can see that the instantaneous velocity is not constant between T1 and T2. Why is that so? The instantaneous velocity is the tangent to the graph, the slope of the tangent to the graph at any point in time. You can see that the tangent is not going to be the same at every point, at every t. Can you see that? Because it's not a
Yes.
linear graph. It's only when you have a linear graph that the slope is the slope is constant. So the slope will not be constant. Indeed, when the graph is minimum or maximum, the slope will be 0 because the function is turning at that point. Is that okay?
Yeah.
Yes.
So I will now ask a question. Under what condition will the instantaneous velocity be equal to the average velocity?
When the
Notice that
acceleration is zero.
When the acceleration is zero, sir.
Yes, when the
When
acceleration
there
is
is no
okay,
change
that's
in
brilliant.
When the
acceleration.
acceleration is zero.
Okay, the slope is the straight line, is the line itself or a line parallel to it, right? As such, the
Yes.
slope of a straight line is constant. Clearly, you can see that average velocity will be equal to instantaneous velocity if the graph of s versus t is a straight line.
Wow.
The slope of a straight line is constant. For such a situation, the velocity is constant and the body is said to be a uniform motion.
Motion.
We can then say that instantaneous velocity is the same as average velocity if a body is a uniform motion.
Motion.
As you can see, that is the graph on that page. That body is in uniform motion, and the slope of that straight line is, of course, constant. Notice that in the figure above, that is in the on the previous
Where
page
did the
now, the
last?
straight line joining the curve at the 2 points is an approximation, that is the one before. It's an approximation to the curve, right? This one is an approximation to the curve, but this one is not an approximation to the curve. It's the curve itself. While in the linear graph, the line is not an approximation, but the graph itself. The slope of an ST graph is velocity. The area under the ST graph is the distance traveled by the body. Now, what is uniform motion? We say a body is uniform motion if it makes equal displacement in equal intervals of time. It means that its velocity is a constant. Now, a vector is constant only if its magnitude and its direction are both constant. Since the magnitude of the velocity is associated speed, constant velocity means the speed must be constant as well as the direction. Thus, a body in uniform motion must be on a straight line and must have a constant speed. A body not moving on a straight line is not in uniform motion, even if its speed is constant, because the velocity is changing in direction. A body is in non-uniform motion if it makes unequal changes in displacement in equal intervals of time. Understood?
Yes,
Yes,
sir.
sir.
Yes,
Let's
sir.
Yes, sir.
take a
Yes,
look
sir.
at acceleration. In just the same way as we defined average velocity, we can also define average acceleration. The acceleration of a body is the time rate of change of its velocity. It's a vector measured in meters per second squared. Just as we had it under velocity, the average acceleration is defined as final velocity minus initial velocity divided by the time taken. From that figure, that would be V2 minus V1 over T2 minus T1. Please, V1 is that point that is dotted point on the lower part of that graph, the horizontal line. That will be V1. Then T2 is the other side of T1, that is where the dotted line comes down. That is T2. Instantaneous acceleration is the time rate of change of the velocity. This can be achieved by letting T2 tend to T1 in that last equation. So that will be equal to dv dt, which is limited as T2 tend to T1 of V2 minus V1 over T2 minus T1. This is the slope of the function at the time t equals T1. You can see the instantaneous acceleration is not constant between T1 and T2 because yet again, the slope, the tangent to the curve is not fixed. It changes as time goes on. The average acceleration will be equal to the instantaneous acceleration if the graph of v versus t is a straight line. We are just repeating what we did talk about under velocity. The slope of a straight line is constant. For such a situation, the acceleration is constant, and the body is said to be in uniformly accelerated motion. We can therefore say that instantaneous acceleration is equal to average acceleration if a body is in uniformly accelerated motion.
Motion.
That's the example you can see there. So we define it. The body is uniformly accelerated. The body is uniformly accelerated if it makes equal changes in velocity in equal intervals of time. And the body is in non-uniformly accelerated motion if it makes unequal changes in velocity in equal intervals of time. We can illustrate what we have learned in the two figures, one on the ST graph and one on the VT graph. Look at that ST graph.
Sir, please, I have a question.
What's the question?
Sir, like I also want to know what's the difference between instantaneous acceleration and average acceleration.
What is average acceleration class? Final velocity minus
Final
initial
velocity.
velocity. It does not take into consideration what happens between T1 and T2. Can you see that?
Okay.
Does it take into consideration what happens between T1 and T2? No.
No.
But instantaneous velocity acceleration takes into consideration what is happening at that particular instant of time. We're going to see an illustration of this later. Look at the graph in front of you now. The first horizontal bit, what is the velocity? 0, right? S is constant. The next set of lines are slanted, straight line. The first one has a positive slope, the second one has a negative slope. These two denote uniform motion. The first one, the velocity is greater than 0. That's why the graph is slanting positively to the right as t increases. So velocity is greater than 0. For the second one, the velocity is less than 0 because it's slanting as t is increasing. S reducing. And then the final diagram there is for non-uniform motion. You can see the slope is not constant because velocity is not constant. We can take that to the next figure, in which case we are drawing V against T. A is 0. The second set, A is greater than 0, constant. A is less than 0, constant. Then the last one is for non-uniformly accelerated motion. Are we okay with these diagrams? With these figures?
Yes.
Is it time already?
Yes.
Is it time?
Not yet.
No, not yet, sir.
Sir, please, after the class, I just wait down. I just run down of it.
Acceleration or retardation?
14 minutes.
Acceleration that is opposite velocity is called retardation. It applies only if the body is slowing down. If the body is going to the right and slowing down, the acceleration is to the left and negative. Retardation is negative of the acceleration. If the car is moving to the right and slowing down by 2 meters per second every second, the acceleration is minus 2 meters per second squared. Or it has a deceleration of 2 meters per second squared. In this case, the acceleration is opposite in direction to the direction of motion. Therefore, it is slowing down. But if a car is moving to the right, it suffers retardation only if it is slowing down, meaning that there's an acceleration to the right, opposite its motion. The acceleration is the retardation. Note that not all negative acceleration is deceleration. If a car is moving to the left and speeding up, then its acceleration is negative. It is not decelerating because it is going faster. Deceleration applies to slowing down. If it is slowing down while going to the left, the deceleration will be positive, the same as the acceleration. As another example, when a body is projected vertically upward, it suffers retardation on its way up because the acceleration is due to gravity is directed in what direction? Downwards. It slows down until the velocity is 0. It starts coming down. The velocity keeps increasing as both the velocity and the acceleration are now negative. Or put another way, direction which is down. Acceleration is negative, but the body is not
I have a question. I have a question.
Go on, please. Go on.
Okay, so you said the velocity is increasing as the body is going down. Is the acceleration not supposed to be positive?
acceleration is not positive because, as we are going to see, it's pointing down. We are going to see that when the body is going up, if the acceleration to gravity, is it pointing down or pointing up?
Pointing up.
Pointing down.
Pointing down now.
Pointing down.
Gravity is
That's negative or
down.
positive?
That is positive.
That's negative. A vector
Please,
pointing
sir.
downwards is negative, right?
Please, sir. Yes, sir. Please, sir,
Go
when
on,
the
please.
body starts, please, sir, when the body starts coming down, doesn't that mean that the acceleration is now positive because the body is directed downwards? Why is the acceleration
Yeah,
still negative?
Is it moving in the positive direction or negative direction?
So I'm saying when the body starts coming down,
Is
like
that
after
body
the
moving?
velocity is
Is
zero,
that body moving down or moving up?
it is moving down, sir.
So is it moving towards the negative or towards the positive?
Negative.
Negative direction.
Negative. Don't forget
Okay,
that F
sir.
equals mg, right?
Yes, sir.
So is the F positive or negative?
Negative.
Negative, right? Because it's pointing down.
Yes,
Mass
sir.
is positive. F is negative. G is also negative.
Thank you,
right?
sir.
Sorry, sir.
Welcome.
Sorry, sir. I don't understand that part too. About the acceleration being negative when it's coming down. Because it's like towards acceleration due to gravity. So why is it still negative?
Is acceleration to gravity positive or negative?
The acceleration is coming down is positive.
It's positive.
Acceleration to gravity
The body should be moving up.
Yes, sir.
Is that okay now? G is negative.
For it to be negative, it has to be moving up.
If it's negative, it has to be going up. But if it's coming down, it's supposed to be positive.
Under gravity now.
You have to disconnect from what you are taught in your various secondary schools. Do you understand? And that's what I tried to explain in the last
That
paragraph.
is what he's saying now. That is what he's saying.
Okay.
That is what the man is saying.
In your secondary school, you have two equations for motion up and one set of equations for motion up, another set for motion down, right?
Yes, sir.
Yeah.
In this case, you are going to have only one set of equations that will satisfy both motion up and motion down because your acceleration is pointing down at all times. Is that also? That's why I told you that when the body is moving up, its velocity is positive, right?
Yes.
But the acceleration is negative because it is always pointing down. That's why the body slows down on its way up. Until it gets to zero. That is why the velocity is able to reduce to exactly zero and then start increasing in the negative direction. Okay?
Proceed,
When you
sir.
say a body is in free fall, when you say a body is in free fall,
When the body
Coming down without any
is it only when it's moving down?
Without air resistance.
A body is in free fall if the only force acting on it is gravity. If it is going up, it is still in free fall. Okay?
Please, sir, continue, sir.
So what you're trying to say is that whether a body is going up or a body is coming down, acceleration is always negative. Is that what you're trying to say?
It's already there. Another example, the last paragraph.
Yes.
So acceleration can be
Acceleration can never be. Can they hear me? Can they
the
hear me?
magnitude you took into consideration in your secondary school.
Acceleration can never be negative
You understand
in
now?
other ways.
Huh?
When it is going up, it is retardation. That is why it is
I wish I'll be the one to teach you motion under gravity. You see what I'm talking about? Okay, let us look at the equation of motion when the body is going up. What will it be? V equals U minus GT,
Minus
right?
GT.
Yes,
Minus
when it's
GT.
going up.
When it's going up, minus.
Initially, T is 0, right? Hello?
Yes, sir.
Initially, T is 0.
U is
just equal to U, right? As T increases, what happens? Does U change?
Yes, U
does not change.
U doesn't
It
change.
doesn't change.
It doesn't change.
GT now starts increasing, right? GT starts increasing.
Yes,
Until it is
sir.
equal to U. It is equal to U when the body is at the maximum point in its
Yes,
gravity, right?
sir. Yes,
Sorry,
What then
sir.
happens
Can
thereafter?
you come again, sir?
Zero.
As T increases, PT increases, right? But it is negative because of minus GT, right?
Yes, sir.
That is why the velocity starts, continues to decrease until GT is equal to U.
Okay.
When PT is equal to U, T equals U over G, right?
Yes, sir.
And V is 0.
Yes.
What happens thereafter? GT continues to increase as T is increasing. Because it is carrying a negative sign, it is now more than U. So V is now negative. That is why the body is now coming down.
Down.
V is negative because it's now directed downwards. Can you see we are still using the same equation, V equals U minus GT.
Yes,
Whether
sir.
the motion is up or the motion is down. Can you see that now? So please, forget about that you are taught in your secondary school. You are going to use only one set of equations. But if you get to that part of this course, and whoever is teaching you still chooses to teach you using the two different values of A, just flow along with it. It's still the same thing. Do you understand?
Yes, sir.
Yes,
Now
sir.
consider the general case of a body that is uniformly accelerated from an initial velocity U to a final velocity V. It means that the body did not start at rest. The body starting from rest is a special case of uniformly accelerated motion. Why is this body uniformly accelerated? It's a linear graph. V versus time is a linear graph. The slope of the line is the velocity of the body, right?
Yes.
What is the slope? V minus U over T. Hence, V
Acceleration.
minus U is equal to AT, and V equals U plus AT. S will be UT, that is the area of the rectangle. We said earlier that the area under the ST graph is the distance traveled. What is the area of that rectangle in the diagram? UT, right?
UT.
Yes, UT.
What about the triangle? Half base times height. Is half T times V minus U. This will be equal to UT plus half T. I did a little bit of abracadabra. I divided V by minus U by T and multiplied by T. Have I done anything wrong?
No, sir.
Okay. You recognize V minus U over T as A, right?
Yes.
What would this give us? UT plus half AT squared. The area under the graph is that of a trapezium with parallel sides U and V. Look at that. The parallel sides are U and V. And the perpendicular distance in quotes between them is T, right?
Yes.
Yes, sir.
Use the area of a trapezium.
There's something. Yeah, this book.
Okay, are you with me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, that will be half U plus V times T. That will be half V plus U. What is T? T is V minus U over A. Go back to the expression before. The slope of the line is the velocity of the body, right?
Yes,
If
sir.
you are looking at the subject of the formula, just replace
Sorry,
interchange
sir.
A and T, right?
The slope of the
Interchange
line, is it velocity or acceleration?
Acceleration.
This is VT diagram, not EST diagram.
Okay.
So T will then be equal to V minus U over A, right?
Yes.
Yes, sir.
So half into U plus V. Instead of writing T, V minus U over A, which will be equal to 1 over 2A into V plus U into V minus U, which is 1 over 2A. Difference of two squares. v squared minus u squared.
Squared.
Hence, s equals 1 over 2a into v squared minus u squared. If you turn that around, you arrive at v squared equals u squared plus 2a.
Yes.
Then retain the earlier formula. S equals u plus v over 2 times t. So we have all the 4 equations we needed for
motion.
Uniformly accelerated motion. Please note that these equations are true only for uniformly accelerated motion. Because you assume the straight line graph. We now interpret this to mean that the distance traveled is the average velocity times the time taken. Times, not time. S is missing. Times the time. But we have to be careful. This is not the average velocity that we saw earlier. Let's just say the average of the velocities. I will reframe that. Average of velocities times the time taken. How should you make use of these equations? As much as possible, make use of what you are given. And only what you calculated, only if you are constrained to. This is because if you make use of a value you calculated and made a mistake in the calculation, this mistake will be carried forward into other calculations. Let us take some examples. A body starts from rest and accelerates uniformly at 2 meters per second squared for 5 seconds. Draw the VT diagram, calculate the final velocity, and calculate the distance traveled. U is 0 meters per second, right? Because the body started from rest.
Yeah.
A is 2 meters per second squared, and T is 5 seconds. The VT diagram is as indicated. Indeed, for you to get one right, you should have done 2. Our V in the VT diagram should have been labeled 10 meters per 10, right? Velocity is already meters per second. Put 10 there. So in this case, you may first take question 2 before you take question 1. Then for 3, we can make use of S equals U plus V over 2 times T. S equals U T plus half A T squared, or V squared equals U squared plus 2S. So which of these are we going to pick? If you look at the second and the third equations, depending on what you calculated, it will make, if you made a mistake while calculating V, that mistake will be carried forward, right? So make use of what you are given. That will be S equals U plus V over 2 times T. You are given U, you are given V, you are also given T, right?
Please, sir, we're not giving V. We calculated V.
For 5 seconds.
Is that? That's time.
5 seconds is the time.
Please, sir, we calculated V. We were not given V. Final velocity. We calculated
We
it.
calculated T. I mean, we are given time, T.
Yes, sir, we're giving time, but we calculated final velocity.
That's why I'm telling you not to use that form. Okay, S equals U plus V. Okay.
Yes,
Which one is appropriate now? You use the second one, right? S equals U plus
half AT squared.
Let me see, I'm following.
Excuse me, sir.
There are some other examples there. So please take a look at them. If time permits, we go back to this. The time for our class is over, right?
Yes, sir.
Yes, sir.
Sir, time for the class to go.
Yes, sir.
Please continue.
Yes, sir.
Meet you guys.
Hello, sir. Sir,
All
please,
right,
can
so
we get
everybody
the
make up
slide?
time.
No, ma, you're
Hello,
going
sir,
to
can we get the slide?
I'll send the slides to you.
Sir, where?
You're good.
Obviously,
Has
Don't
he
worry, the
finished?
slides will
Is he
get to
done?
you. All right then. Bye.
Sir, please,
Bye,
can you
sir. Thank you, sir.
Thank you, sir. Bye.
Sir.
Sir, thank for the class.
Sir.
Bye, sir.
Bye-bye, sir. Thank you, sir. Bye.
Okay, sir.
Sir, what is class for engineering?
Thank you, sir.
Thank you, sir.
Class for engineering or
Thank you, sir.
Now don't they melt now, just they shout me.
Thank you, sir.
sir, please can you just do quick rundown? Under your palm.
Una go relax o.
Who be that?
Scholars, you can summarize for us, for those of us that are slow learners.
This one now. Na secondary school you dey.
I don't know why na no fit mute yourself. Go dey disturb teacher. Nothing do you now. I don't understand. Read these scholars. I beg, Muna dey mute yourself. I beg. They disturb us. Oh God, they show scholar for you. I beg. This may not be your secondary school now. They mute yourself. They make them teach you how to mute. That's why I go to talk. Go just dey bounce. Go dey make mouth.